Okay, so this is Dr. Nanip. If you do not know me, I lecture every other day on statistics. I also have recorded lots of other videos on solving problems in math, different kinds of math in my channel. So please take a look at my channel. Please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please share my video with my friends. And one request I'm making, please do not quit halfway through, because I'll be covering some important tips at the end of this program. Okay, so please stick around and it will be not too long. So today we are going to talk about variables in statistics. So variable, as you can think about, is something that varies. Okay, what you may not know, there are different kinds of variables. Everything you didn't know about variables I'm going to cover today. Your knowledge about variables may not be complete. That's what I'm saying. So what is variable? Okay, variable, so let's use the singular form, is a characteristic that varies from subject to subject. Such as a person's height, such as height in feet. Okay, so we can have a numerical variable or categorical variable. So variables are of two types: categorical variable, that means they're divided into categories, such as manufacturer of cars, car manufacturers. And you know there are different categories of manufacturers, such as Ford, GM, Toyota, etc. So these are all categorical variables, categories of different car manufacturers. The other type of variable is numerical variable. Numerical variable, the word numerical comes from the word numerical, as you know, is number. Okay, number associated, number associated with this variable. Okay, so there are different types of numerical variable. One is a discrete numerical variable. Discrete numerical variable is something that can be counted or listed. Counted or listed. Good example of that is how many siblings you have. How many siblings means brothers and sisters you have. It can be 0, it can be 1, 2, 3. So you can count how many brothers and sisters. You get that? You're counting. And also notice you're jumping from 0 to 1. You cannot have 0.5 brother and sister. So that is discrete numerical variable. Something that can be counted or listed. The other type of numerical variable is called continuous numerical variable. And this is something that is measured. Something that is measured. how long does it take for my phone to download a song? Now it can be 1 minute, it can be 0.5 minute, it can be 1.5 minute, it can be 0.3 minute. So as you can see, it's continuous variable from 0 to 2 minutes. What do I mean by that? So if you draw the number line, this is 0, this is 1, positive 2. Download time will vary anywhere from 0 to 2 minutes. Decimal values are possible and you are measuring it. Decimal values are possible in this interval. Decimal values 0.3, 1.5, and you are measuring it. Also, it is measured, not counted or listed. That's a continuous numerical variable. Whereas a discrete numerical variable, you count, you list, and you have whole numbers. Okay. So, question is how you collect information from people, how many brothers and sisters, how do you represent the information? Okay. So, say you are into categorical data. Okay. You go to the parking lot of your university and find out how many Ford cars are there, how many GM cars are there. So you make a frequency distribution of categorical variables. Such as different car manufacturers in the parking lot, car manufacturers in the parking lot. So how will you list this table? So you will have car manufacturers, and count or frequency. How frequently each category of car manufacturer occurs in the parking lot. How many Ford cars are there? Say there are 10 Ford cars. How many GM cars are there? Say 20. How many Teslas are there? Say 15. How many Toyotas are there? Say another, let's make it another 15, or make it 24 Toyotas. So what is your total? You add them up, okay, total count. You add them up, 10 plus 20 is 30, plus 15 is 45, plus 25 is 70. So total is 70 cars. What is the proportion of each manufacturer, which is also called relative frequency? Relative frequency. So this whole table is called the frequency distribution. Relative frequency, you take the total of 70 and divide into each. Do I leave it as a fraction? No, you convert it to a decimal to get the proportion of each category. This one will be 20 divided by 70. Next one will be 15 divided by 70. So that's the relative frequency, and the last one will be 25 out of 70. So either you can make a frequency distribution, a listing of the different categories of car manufacturers in this case, and count of the car manufacturer in this case, frequency. So that will be a frequency distribution, or you can convert the frequency into relative frequency. Why? Because that gives you the proportion. What percentage of the cars have Ford? It is, 10 divided by 70, a decimal, multiplied by 100. Shift the decimal point 2 points to the right, you get the percentage of cars which are Ford in that parking lot. Okay, so we talked a lot about numbers, discrete probability, discrete variables, continuous variables, and categorical variables. All this is constitute data. What is data? Data is the plural of the word datum. This is the singular form. It means data itself means collection of information. In our case, in this particular frequency distribution, it is numbers. Collection of information. Okay. So, at this point, I would like to do some some problems so that you get to understand what this all about, how you apply this information in solving practical problems. So that's why I said please stick around till the end, because I'm going to give you some important tips or hints at the end of this program. So let's delve right into it. We are going to solve some interesting problems applying these concepts. Okay, so if you stick around with me, let me turn my board. Okay. So first we will look at some categorical variable. Categorical variable example. Okay. The grades of 16 beaches in a northern California county are listed. Okay, and these are like this: A, F, B, F, F, D, A, F, F, then C, F, F, A, B, and F. Let's count and make sure we have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, we have been asked to calculate or find relative frequencies of A, B, etc. Just let's do A and B. So we count that number of A's. 1, 2, 3 and a 4. So relative frequency is, you take the number 4 and divide into it the total count, which is 16 beaches, is 4 out of 16. 4 goes into itself 1 times, 4 goes into 16 4 times. 1 out of 4 or 0.25. You multiply that by 100. This is what I was talking about in the last, on the other side, how to convert proportions from decimal into percentages. I took 0.25. 1 divided by 4 is 0.25, multiplied by 100. 25% of the beaches are got a grade of A. Okay. Now let's find relative frequency of B. Relative frequency of B. So this is relative frequency of A is 25%. Let's see how many beaches got B. 1, 2. That's it. Okay. Is 2 out of 16. 1 and a 2. So 2 out of 16 is 2 goes into itself 1 times, 2 goes into 16, 1/8, which is 0.125 multiplied by 100%, or 12.5% of the beaches in this Southern California county or Northern California county is rated B, okay, which is about half that of A, okay, and so forth. You get the picture. You can count the number of C's and then divide it by the grand total to get the relative frequency proportion, multiplied by 100, shift the decimal 2 places to the right, you get a percentage. Why do I convert it into a percentage? Gives you what will happen if the total count is 100. For example, 25% tells me out of 100 beaches, 25 beaches are rated A. That's the whole idea. 100 is your basis. Okay, let's do, so this was categorical variable example. Now let's work with the numerical data. So chemotherapy patients survival rate after chemotherapy. Okay, so years survived after therapy, and we have relative frequency. Okay, so 0 to less than 2 is 0.1. 2 to less than 4, 0.42. 4 to less than 6 is 0.02. 6 to less than 8 is 0.1. Okay, then 8 to less than 10 is 0.04. 10 to less than 12, 0.06. 12 to less than 14 is 0.02, and 14 to less than 16 is 0.28. Okay, all this should add up to 1. Sum of the relative frequencies is 1. Let's do a quick check on that. 0.28 plus 0.02 is 0.3, plus 0.06 is 0.36, plus 0.04 is 0.4, plus 0.1 is 0.5, okay, 0.52, let me see, 0.28 plus 1.3 plus 4, 0.5, 0.52, 0.94, okay, I have not missed anything, 0.1, actually, so it is 0.5, 0.52, this should be 0.52, 0.94, and then this should be, I have copied the information incorrect. Then the sum becomes equal to 1.0 total. Let me make sure I've done it correctly. 0.28 plus 0.02 is 0.3, plus 0.06 is 0.36, plus 0.04 is 0.4, plus 0.1 is 0.5, plus 0.02 is 0.52, plus 0.42 is 0.94, plus 0.06 is 1. So, they want us to find out what proportion of patients survived at most means maximum 4 years. Now 4 is the upper point, okay, or upper boundary of this second class. Okay, so the relative frequency of that is up to 4. You not only include 2 to 4 but also the class before it. So it is 0. Because they're surviving up to 2.06 relative frequency, and from 2 to 4.42. So it's 0.06 plus 0.42 is 0.48. What does it mean? For patients will survive at most 4 years after chemotherapy. Okay. Next was what proportion of patients survived at least 10 years. At least 10 means 10 is the lowest. Okay, so 10 is the lowest boundary in this class. So this is this one. And then they can, minimum is 10, at least 10 means minimum is 10. They can survive as high as 16. So you got to add the relative frequency of these last 3 classes. So you start with this class, which is 0.06 plus the next class, which is 0.02 plus the last class, which is 0.28. So this is at least 10. Why, you ask me? Because at least 10 means the lowest number of years of survival is 10. It can be anything above that, and the maximum is up to 16. So you got to take into account the relative frequency of each of the last three classes, which is 0.06 plus 0.02 plus 0.28, which works out to 0.06 plus 0.02 is 0.08 plus 0.28 is equal to 0.36. Or if you multiply this by 100%, it is 36%. Remember the rule, you multiply by 100 two zeros, the decimal shift 2 places to the right is 36%, or 36% of the patients will survive at least 10 and above. So I'm going to call it quit at this point. What we have discussed is, we have, in this side of the board, we have discussed frequency distribution of categorical data, as well as frequency distribution, relative frequency distribution of numerical data. This is categorical data, which is graded into categories, hence categorical data. Here it's number of years of survival after chemotherapy and relative frequency of the different classes. These categories are called classes here because these are numbers, numerical numbers, classes. The lower number is the lower class boundary, the upper number is the upper class boundary. And these are the relative frequency in each class. The sum of the relative frequency should add up to 1, okay, as you would expect, 100%. And then at least means 10 and above, at most 4 means from maximum value is 4, so the first two classes, okay. So that's a tip I want to give while constructing relative frequency. Relative frequency is in proportion, you multiply it by 100, convert it to percentage. Why? Because then you know out of 100 how many people, or what percentage, or out of 100, in this case the last answer, 36 people out of 100 will survive at least 10 years. Okay, I'll stop here today. If you have any question, any comment, please do not hesitate to write me a note. If you like this video, please give me a thumbs up. That really motivates me to produce more informative video and go more times live, so that you can listen to my lecture. And if you like this video, please share it with your friends, and please subscribe to my channel by hitting the red subscribe button, and also please click on the notify button, because then you will be notified every time I upload a new video. That's the bell button. Okay, thanks for watching. Take care, have a nice day. Please do not forget to watch me tomorrow. See you next time. Take care.